our group conducted an experiment using a plug flow reactor. At the upper equipment, the conductivity inlet measures the electrical conductivity of the incoming fluid, while the conductivity outlet measures the fluid conductivity, again allowing for evaluation of the system performance. The temperature reactor is where the main chemical processes occur. Before entering the reactor, the fluid passes through a temperature preheater. Next, it contains the main switch, the heater, and pump 3. Both pump 1 and pump 2 will supply the water. Feed tank B1 contains NaO solution, while feed tank B2 contains ethyl acetate solution. The preheater B5 and the water jacket B4 are filled with water. This equipment also includes a stereo motor M1. At the bottom pipe, there is a waste tank B3.
Experiment for the plug flow reactor. First and foremost, we must switch on the reactor using the main switch at the main control panel. As you can see here at the main control panel, there is the main switch, the switch for the heater and pump, and also the reading for conductivity and temperature. As you can see here, the main switch is on, and these are the readings for the conductivity in the inlet and outlet, and also the temperature in the reactor and the temperature in the preheater. Once the mixture has entered the preheater, it will first go through the conductivity meter in the inlet, and it will go straight into the plug flow reactor where it will react. After reaction, it will go out into the conductivity meter in the outlet and straight to the waste tank.
The system consists of two tanks. The tank on the left contains the sodium hydroxide solution, while the tank on the right contains ethyl acetate solution. These reactants will be fed into the reactor at controlled flow rates. At the bottom of each tank, the outlet pipes connected to a network of valves and tubes. These valves control the flow of reactants into the reactor. These reactants from both tanks travel through this pipe where they are mixed before entering PFR. The reactants flow continuously through this reactor, reacting along the way.
A function of plug flow reactor experiment in a lab is to determine the reaction rate constant and understand the kinetic of chemical reaction taking place within the reactor. Next, to measure the conversion rates of reactant to produce at different flow rate and residence times. Lastly, to analyze the distribution of residence time of reactant within the reactor, which help in understanding the flow characteristic and mixing pattern.
For function of plug flow reactor in industry, they are essential in processes like oil cracking and reforming, where hydrocarbons are broken down into simpler molecules. Next, PFR are used in the manufacture of polymers, including polyethylene and polypropylene, due to their ability to maintain consistent reaction conditions. Lastly, in the pharmaceutical industry, PFRs help in the synthesis of active pharmaceutical ingredients by providing precise control over reaction times and conditions.